Okay, simplifying a complex expression. If you're taking a quantity squared, you've got to rewrite that as 1 plus imaginary times itself, 1 plus imaginary. So you cannot just take the exponent 2 and take it to the 1 and take it to the I. You need to times that whole thing by itself. So distributive property, 1 times 1 is going to give you 1. 1 times I is going to give you 1I. I times 1 is going to give you 1I. Then I times I is going to give you negative 1. And a negative 1 and a plus 1, 0 out, and a 1I and a 1I. So you're going to have 2I on top. On bottom you got I cubed, so you got I times I times I. I times I is a negative 1. So you got 2I over a negative 1I. And I over I divides out, so you just got 2 divided by negative 1, you got negative 2. 14, what's the range of this function? So the range and the domain are easier to tell if you're looking at a graph. So you need to type this into your calculator and look at the graph. And the graph goes something like this. So the range is the up and down. How far up does it go? How far down does it go? You need to find the vertex. Well, the vertex in this case is going to be the minimum. So it's the lowest point of the graph. This graph is going to go on forever up, so it goes all the way to infinity in the up direction, but the farthest down it goes is right here at the vertex. And that happens at, if you count down on your calculator, it comes down all the way to negative 9. So anything greater than or equal to a negative 9 is going to be the range. Okay, the solution, that's the same as roots or zeros, so they want you to, it's quadratic, you can use quadratic formula. So first you've got to get this over here, so plus 5, so we got x squared minus 4x plus 9 is equal to 0. So move number 1, get everything together. Okay, now, your A, if your A ever starts with 1, it might be easiest to just factor it. So B is negative 4 and C is 9. So A is 1, so I'm going to try and factor it. So does there exist some number that times and gives you 9, but adds and gives you a negative 4? And you can use a 1 and a 9 or a 3 and a 3, but there's no way to add these and get a negative 4. So you can't times and get 9, add and get negative 4. That means they're not easy solutions. They're going to be some kind of fraction or square root or even imaginary. So let's plug them in the quadratic formula. Quadratic formula is going to be the way to go. So x equals negative b. A negative 4 is a positive 4. Plus or minus square root b squared. Negative 4 times negative 4 is positive 16. Minus 4 times a. I'm not even going to write it. Times c. All divided by 2 times a. So this is going to be under the square root. It's going to be 16 subtract 36. So I've got 4 plus or minus the square root of a negative 20. All divided by 2. So I'm going to take the negative out and that becomes imaginary. So it's going to become 4 plus or minus an imaginary times square root of 20, all divided by 2. And square root of 20, you got to pull squares out of that. So 20 is going to break down to a 4 times a 5. 4 is going to be a 2 times a 2. So there's a square that's going to come out. So you're going to trade 20 for 2 on the outside, and this 5 is left over on the inside. So we got this. We got 4 plus or minus 2i times the square root of 5 divided by 2. Now you can divide both of these by 2. So it's going to be 2 plus or minus I times the square root of 5. So it's the 2 plus I squared of 5, 2 minus I squared of 5. Same thing on here. A is 1, B is a negative 4, and B's always been a negative 4. C is going to be 5. So if A is 1, try and factor first. So does there exist something that times and gives you 5, adds and gives you a negative 4? You can do 5 and 1, but that'd have to be a negative 5. Plus 1 will give you negative 4, but negative 5 times 1 gives you negative 5. So you can't times and get a positive, add and get a negative 4. So we're going to use quadratic formula. So x equals negative 4 plus or minus square root. B squared is going to be 16 minus 4 times A times C, all divided by 2. So this is going to be 16 minus 20. So we get 4 plus or minus the square root of a negative 4 divided by 2. And that negative 4, that's 2 imaginaries, so we got 4 plus or minus 2 imaginaries divided by 2. Divide both these by 2, so it's going to be 2 plus or minus an imaginary. So it's going to be C. Okay, now you're given an expression, you just need to simplify it and put the real part first and the imaginary part second. So this first is a multiplication problem. Multiply 3i times 10, that's going to be 30 imaginaries. Multiply 3i by a negative 6, it's going to be negative 18, and imaginary times an imaginary is a negative, so that's going to turn that positive. And then this is just all a plus, so plus 7 minus 3 imaginaries minus 4 imaginaries, because square root of negative 16 is 4 imaginaries, so add your imaginaries. 30 minus 3 minus 4 is going to be 23 imaginaries, and then add your reals. 18 plus 7 is going to be 25. So the real first, and then your imaginaries last. Select all that are going to give you something similar to 4i. So we kind of got to go through them one at a time. 3 minus 3 is 0, but 2i minus 2i is 0 as well, so that one's no good. Okay, 2i squared. You need to do 2i times 2i. So it's going to be 4. I times I is a negative. And then you need to times that by I cubed, and I cubed, that's a negative. So that negative is going to make that negative positive, so you got 4i. So that one works. 2 subtract 2 is 0. 2 imaginaries subtract a negative 2 imaginaries is plus, so that one works. That's 4i. 2 times 2 is going to give you 4. 2 times I is going to give you 2i. 4 plus 2i is not 4i, so that one's no good. 1 times 2 is going to give you 2. 1 times 2i is going to give you 2i. I times 2 is going to give you 2i. And I times 2i is going to give you 2. I times I is a negative, so that's a negative. This negative 2 and this positive 2 zero out. This 2i and this 2i is going to give you 4i, so that one will also give you 4i. That one works. And that is it.